Hello everyone! Ever wondered how Spark can turn raw data into valuable insights at lightning speed? Let's dive into the world of Spark transformations and uncover the secrets behind its powerful data processing capabilities. Spark transformations are operations that create a new RDD from an existing one, defining a data processing pipeline but not immediately executing it. Some examples of transformations are map, filter, and group by functions. Transformations are lazy, meaning they do not immediately compute their results but instead define a new RDD. The actual computation is deferred until an action is performed, allowing Spark to optimize the overall processing workflow. Here is an example that illustrates how Spark optimizes the lineage of transformations. Let's say we have a data frame containing employee data, and we want to perform a series of transformations in an action. Read the employee data. Filter employees by a specific department. This transformation filters the data frame to keep only the rows where the department is engineering. Map to a new data frame containing only employee names. This transformation selects only the name column from the filtered data frame. Count the number of employees in the specific department. This action counts the number of rows in the data frame containing only the name column. Show the result. When the transformations filter and select are defined, they are not immediately executed. Instead, Spark builds a lineage graph that is a logical execution plan for these operations. Before executing the count action, Spark analyzes the lineage graph. It realizes that the intermediate step of selecting only the name column after filtering the engineering department is unnecessary for counting the rows. Spark combines the transformations and optimizes the execution plan to perform filtering and counting in a single step, avoiding an unnecessary column selection step. By combining these steps, Spark minimizes the amount of data processed and avoids intermediate data storage, resulting in a more efficient execution plan. Key characteristics of transformations. Lazy evaluation. Transformations are not executed immediately. Spark builds a lineage of transformations to determine the most efficient way to execute the entire data flow. Immutable RDDs. Every transformation results in a new RDD. The original RDDs remain unchanged, ensuring immutability and allowing for consistent fault tolerance. Parallel execution. Transformations are designed to be executed in parallel across the nodes of a Spark cluster, leveraging distributed computing to handle large-scale data processing efficiently. Types of transformations. Transformations can be broadly categorized into two types: narrow and wide transformations. Narrow transformations. These transformations do not require data shuffling across the partitions. Each input partition contributes to a single output partition. Here are a few examples of narrow transformation: map, filter, flat map, sample. Wide transformations. These transformations involve shuffling data across the partitions, as each output partition may depend on multiple input partitions. Here are a few examples of wide transformation: group by key, reduce by key, join, distinct, repartition. Common transformations in PySpark. Map applies a function to each element of the RDD and returns a new RDD with the results. Filter returns a new RDD containing only the elements that satisfy the predicate function. Flat map, similar to map, but each input element can map to multiple output elements. Flattened result. Group by key groups the values for each key in the RDD. Reduce by key combines values with the same key using the specified associative reduce function. Join performs an inner join between two RDDs based on their keys. Distinct returns a new RDD containing the distinct elements of the original RDD. I trust you found this video helpful. Thank you.